You go up to the automotive repair shop because your car's broke.
Yeah. The pilot.
And you want to know
What's that say? Value?
absolute value. You want to know how much it's going to cost you to get your car fixed. And so they tell you that they're going to charge you $50 up front, regardless.
They're crazy. That's what I'm telling them.
Okay, just
My car
let's
worth
just.
$50.
They charge you $50 for looking at it,
Wow.
and the first hour. Okay, so up to an hour of looking at it, they'll charge you $50. After that, it's $35 per hour. Now, let me ask you this. Let's say they work on it for an hour and 20 minutes. How do you think you're getting charged? By the hour, right? They're going to charge you the $50 and they're going to charge you for another hour. Do we all agree with that? They're not going to charge you for half an hour. They're going to charge you whole hours. If they go over an hour at all, they're going to round up to the next hour. We all know that, right? Okay, so this is the easiest way, I think, to understand a step function. If I graph this, let's say that this is my cost
Who made the graph?
and these are my number of hours. Okay?
Who invented the graph? Because I don't like them.
Okay.
You know, my dad has a desk outside his classroom to put bags open.
These here. That'll be the easiest. So tell me, Luke, since you have so much to say today,
Okay.
how much does it cost you at 0 hours?
50.
Nothing, right? Well, actually, it's going to cost you that $50, right? But you're not going to pay for nothing. So I'm going to put an open dot there. Okay? But at 1 minute, how much are you paying? $50, right? At 1 hour, on the dot, how much are you paying? $50. I'm going to put a closed dot there. Okay?
I don't understand why you put a close and an open.
Because it includes it. Okay? At 1 hour, if it's 1 hour on the dot, it's going to be $50. But what happens whenever you go 1 minute past an hour? Another 35, right? So $85. So all of a sudden I'm up here. I'm going to put an open at 1 hour because at 1 hour it's not $85, but anything past it, it becomes $85 all the way up to 2 hours, right?
All the way up
Picking up what you're
to
putting down.
$2.
I understand that.
Because you're
All right, so remember closed means includes and opens means does not
Can I
include.
try and explain it?
Try and explain it.
Okay, so the first open is because they're not paying for nothing, and it's on
Right.
the line of 0. It's on that line. And then the second one,
Could
the
have
op-
included.
exactly, and the second open dot
That's what I
is
said,
on
right?
the first hour. Yeah.
Go ahead, that's okay, go ahead.
The second open dot is on the first hour because they haven't passed the first hour yet. There you go.
I'm
That's
just
all,
saying,
that's all you need to know. If you don't
they
understand it, that
85.
sucks. All right.
Then go over a second opener.
Right.
A millisecond.
A millisecond,
Quarter
yes.
of a millisecond.
All right. So what happens? What would the next little piece of this graph look like?
Plus
Open
35.
above 2 and then closed.
But it'll keep going.
Uh
how
huh.
far
So
does it go?
what's 85 plus 35?
110,
So somewhere around here.
I guess.
At 3 hours, it's going to be inclusive, and it's going to go here. So it's rounding up. Do we see that?
Yes.
110, it's 120.
Yes, 120.
That's fine.
Okay. Well, where I got. Do you see where we're going with this? And it would continue. This is what we call a step function.
But when do you stop? They keep going forever.
Huh?
You stop whenever they're
They can
done.
like literally keep going forever. So when did it say they stop?
Well, there is no. It's an infinite graph, so you would just keep graphing.
How
many times?
I mean, you don't have to keep graphing the whole thing, but I'm just saying we graph a couple iterations
But
of
if they
it.
were like, we only stayed for this many hours, then we could know.
You would grab.
Then you would know, right.
So they say for 3
Okay,
hours.
so now you've got this nice graph where you said, okay, how much would it cost me for 2.5 hours worth of work? And I'd go to 2.5 hours and come here. Oh, that's my 120, right? Does everybody see what we're doing
Oh,
here?
I see that.
Indeed.
All right. So we use what we call a step function, and in general, real world are going to do this where we start with the open dot and end with the closed dot, okay? But we use what we call the greatest integer function,
I forgot what an integer is.
whole number.
Can explain it to us?
What, Ren?
And it looks a little funny, okay? It looks like I'm going to use the notation your book uses here,
Okay. That's absolute value right
okay?
there.
It's not absolute value.
It is.
It's greatest integer. No, absolute value is one line
Why is there 2 lines?
because it's greatest integer
They just
function.
Roman numerals.
This is something new.
I swore that was
Okay.
absolute value.
This is a type of step function, okay? What the greatest integer function does, and this is, you can reference this on your calculator. There's a greatest integer function on your calculator. It's called step. I think it's called step. I have to look. I can't remember what it's called. But anyway,
It's like X plus one.
what this does is this says, yeah.
Does the, outside bracket reverse to absolute?
No, it's really, this is just a double bracket to indicate step function. What it tells you, it's an operation, just like absolute value is an operation. It tells you whatever you put in here, it rounds down to the nearest integer. An integer is a whole number. Okay? So if I told you that f of x was the greatest integer of x, and then I said, what is f of 2.3? What do you think that would equal? 2. How about f of negative 4.1? Negative 5. You got to go down to the nearest integer.
Dude. Oh, because it's negative.
Oh, you're trying to trick us there.
I tried to trick you a little bit.
So when are those brackets moved?
Oh,
Those brackets moved?
bless you.
Like, when would you see those?
We're going to graph them. We're going to be graphing them. All right, so look at this. Let's graph the parent function f of x equals greatest integer. Yeah,
Negative 4.7 will still be negative 5.
correct.
Wait, also, so anytime you see, like, f of x in the decimal, do you do that?
Yes,
Yes.
round down for greatest integer. Yep.
What's the point of that, though? Like, I don't understand why we need it.
Wouldn't
Well, what I just showed you was one example of a step function. This is another step function.
This is the third part.
This is kind of like when you learn to graph lines, and then you learn to graph parabolas. And this is another
this the
type
last
of
third?
function.
Is this the last third? You said 3
Two.
parts to
There's absolute value also.
Is it absolute value?
No, this is not absolute value.
It looks like
Yeah.
it though.
Negative 5, you round down to the lowest number. So if you think about a number line, if negative 4
Yep.
is here, so you're at negative 4.1, so the closest one below it would be negative 5.
So it's like the farthest from zero.
Yes, yeah. All right. Back to this one. All right, now I want you to think about this. Every single value, it's rounding down to the nearest integer. Okay, are y'all with me on that?
Yeah, I'm with you.
Yeah.
All right, if we plug in 0, what is the value? So what is f of 0?
0.
0, right?
Absolutely.
0.
So it would just be
It's a
0
closed
because
dot.
of the decimal.
Wait, is it just
Yeah.
gonna tell you that x is 0? Or?
No, we're graphing this right now. All right, think about this for just a minute.
Wait, hey, it's closed dot or open dot.
Because what is 0 when you plug it in?
Well, 0 actually looks like an open dot.
No, what is f of 0?
Oh. 0.
0.
Wait, so if it was like 4.1,
It's actually that value, right?
so if it, so you have 4.1, you do open dot before?
Okay, I think you're trying to get there. Hold on just a second. Let me show you. All right, tell me what is f of 1?
1.
1, right?
Absolute value, that's at its finest.
I need to know what's going on in between here. Do you agree? What is f of 1/2?
One. Nope, it'd be 0. Definitely 0.
No, it's definitely 0. It goes down to the nearest integer, right? So 1/2, 0. What is f of 3/4? 0. What's happening all the way up until you hit 1? But what happens, what are all these numbers? If you plug in all these x values, what does it spit back out? It gives you 0 every time, right?
0.
All of these are 0 until you hit 1, right? At the value of 1, it pops up and becomes 1. So this is an open dot,
And then we open dot at 2 then, right?
okay? No, this is not absolute value. This is step function.
Open dot at
Well, then it would just keep going that way.
Now we're going to keep going. So let's look. If I go even further this way, at 1.5,
1.
it's still 1, right?
Yeah.
1 3/4 is still 1. It doesn't stop until we get to 2, at which point it's going to jump back up and become 2.
It'll literally just, but what's the, like, it's never gonna change, so what's the point? Like, it's all, that graph's always gonna be the same.
It is, but what's going to happen is I might ask you what's the greatest integer of 2x, and I might put a 2 in there.
2x?
Right, right, yes, and then round. You see what I'm saying?
Yeah, that's pretty.
All right.
That's pretty.
This is what we call the parent function. There's been nothing done to it. It's a basic function. It's kind of like if we had the line y equals x. Okay, that's a basic slope with a y-intercept of 0. As we start changing things, our line starts changing. This is your basic parent graph of a step function. Okay? And I could keep going with this once you get the hang of it. It's a function, remember. I defined it as a function. If it won't pass the vertical line test, you've done something wrong. Yes, ma'am.
Is x always gonna be x?
What do you mean?
The x is according to x.
No, you'll have to figure those out.
Wait, so what would we give it a graph?
You'll be given this equation and said graph. Well, yeah, we're going to do a couple more. We're going to do a couple more. No, they don't connect. Yes, ma'am. Correct.
It does, because one's closed and one's open.
One increase
Oh, wow.
Do you see why this is piecewise? It's a type of piecewise
Why is
also.
it-
It's a piece.
It's made up of all these pieces. Remember those ones you did on that homework? And we restricted them between two values and they were all horizontal lines? It's the same kind of thing.
So that for the day?
You were essentially doing a basic
I feel
step
like this is easier
function.
than
No.
That's so easy. honestly.
Okay, so this is the parent graph.
Okay. Oh, this is their dad. Sorry.
Be their granddad.
Tell me this. Look at this. Look at this graph and tell me what's the domain.
Everything.
0, 0.
Literally.
Literally everything. You can plug in anything you want to plug in, but what's the range?
It would be 1, 2, 3, 4, 5, 6.
So I'm gonna have to write that in set notation. There's just no other way to do that. So like 1, 2, 3, and keep going like that.
Yeah, but how far?
Or you could write all integers. The y can only be integers. That's what step function does, is it forces all your y's just to be integers. Okay?
So would I have to even put that in there? Like, if I was to say
Yeah,
all integers?
all integers. You can say all integers, that's fine. The
All
range.
whole numbers.
So do we have,
And I'm gonna give you some of these on your homework where it's gonna have some numbers in here, and I want you to T-chart it out and try to get those, because I need to get absolute value. You're probably gonna need to do T-chart some of them. Or do
Like, you
this.
can put like the x equals the y.
Or
equals
this.
the
What are
z.
you lost on?
why is that?
So we can graph it, it's already written there.
So do you have to at least do like 30?
I just saw your dad.
Like, if you just keep going on?
Yeah.
Like, I'm just confused.
Like how, I think that's how
What,
far
three?
you can go.
Like, where did you just pull the one out of nowhere?
Yeah, that's my question.
Like, I don't get like how.
Okay, so whenever you're talking about greatest integers, you really want to plug in some fractional values. You're going to want to do your whole number values, okay? So you're gonna wanna know what is it whenever I plug 1 in for x, 2 in for x, and 3 in for x. But you're also gonna have to check some fractional values and because that's what the greatest integer does, is it rounds to the nearest integer. So you're gonna need to know at what point it starts bumping to the next integer. And once you get the pattern, and it shouldn't take you many of them to catch on to the pattern, then you won't need to work them all out. Okay? All right.
So like those little points would be 1/2 0, or
Where did it go?
It went down there at the
Here it
bottom.
is, here it is.
What is that?
All right, listen, let me show you absolute value because we're going to be out of time.
I swear we have.
I know, I don't know where the time goes in this class. Let's talk about absolute value real quick because y'all have
So
been.
much fun.
Math is so fun.
All right, absolute value. I'm gonna come back and do a step function that's got some other values in there so you can see what happens. If I don't get to it today, then I'll post you a little snippet of last semester showing them. All right,
We just did a step function.
absolute value. Absolute value is not step
No,
function.
I'm saying we just did a step function.
Yeah, we did.
So why do you?
We did a parent function. Like if I gave you, don't write this down. If I gave you this,
Oh, that's still the same thing.
it's the same thing. You're plugging in x values. At 1, y is 2, and you got to find where it switches over.
is that a 2 or a
That's
Z?
not-
That's a
It switches
2.
over at the integers.
Does it?
obviously.
But sometimes it'll cross over more than one
Miss McKee,
value.
So you pick your X, like whatever X you want.
Think about whenever you used to graph lines before you knew how to do the slope and everything else, and you just picked x values. And we're going to kind of do the same thing with our absolute value because we're going to get to something actually in the next lesson where we're going to transform. I'm wondering if I shouldn't just. Let me just show you absolute value. I'm going to let you use your calculator on it, but we're going to really graph absolute value in depth with some transformations starting tomorrow. But let me just show you what it looks like and why we include it in piecewise, okay?
Word. Word.
This is absolute value of x. Do we all agree? Do you see how this is different than the way we wrote step function?
Yeah.
All right.
I guess.
What is special about absolute value?
It's that value.
What does absolute value do?
Like it's absolute.
Turns all the negatives positive, right? Positive stays the same. It turns all the negatives positive. So if I think about this line,
Yeah.
y equals x. It's like this, right? It's got a y-intercept of 0. It goes up 1 over 1. And that's what the line y equals x looks like, right? But if I change it to the absolute value, that means all of my x
It'd be
values that I
0.
plug in,
Well,
if they're negative, what happens to them?
cuts off that. That can't be used.
That can't be, but what happens to
It
it?
gets cut off and only used 0 to.
Well, it still uses it, but it uses it a little bit differently. It does what? Somebody said it. It flips it over.
Oh,
That's
reflection.
this becomes this.
Wait, why would it
Because
lie?
if I was at -1, plug -1 into the equation. What is f of -1? 1. It takes what was negative and it makes it positive. Correct. Correct. Okay? So that's exactly what it does, is it forces it to be positive. So whenever we talk about an absolute value graph,
Wait, so will it directly state like absolute value? Like if you have a question?
it'll say f of x equals absolute value of x.
And then will it give us some numbers to plug in the graph?
You will have to come up with those numbers. I'm going to show you how to graph it on your calculator so that you can get those values, okay? All right, let's take out your calculator real quick. Let me show you. While you get those out, look at this basic parent function. What is the domain of that absolute value?
I lost 2 batteries.
What's the domain here? Y'all can do this.
Negative infinity to infinity.
Yes. What is the range?
The range is 0, infinity.
Bracket, parenthesis,
Yes.
right? All right, here's what we're going to do. And
I
again,
found them.
I don't really agree with the layout of this book and the way that we're doing this because we're going to really focus on graphing by transformation and not by points and this and that and the other. But your book lays it out this way. It's a good introduction, at least, so that you can make the connection between piecewise functions and absolute value and how this is a piecewise. Do you see why it's a piecewise?
I found my batteries.
Good job.
This is y equals x when x is greater than 0. This is y equals negative x when x is less than 0. So it's a piecewise function.
Well, what about the closed and open dots at the bottom?
You can put this inclusive here, and then it, yeah. Just to show you that it's two pieces of two different functions that come together to make that. All right, go into your calculator and hit y equals.
All right.
Hit math
Where is that?
under the green alpha
Oh.
and over to ABS.
I don't see ABS.
Or over to number and choose ABS, I'm sorry.
Oh, yeah.
That's absolute value. Hit enter and do X
Okay. I found it.
and graph. Whoop, I need a zoom 6. Whoop,
I found it.
and there it is, okay? So you can put any absolute value function in here this way.
Can you help?
Can you show me how to make it, it's only on
Bless
what
you.
half.
Zoom
You gotta
6.
press zoom, yeah.
Zoom
Mm-hmm.
6. Ah, beautiful.
Option number 5.
Wait, what are you doing? That's the internet.
What do you notice? What do you think that is?
Oh, that's a step function.
Okay, to do the steps, so if I wanted to know, I think I referenced this one earlier. The greatest integer of 2x and what that looked like, I could come y equals, choose integer 2x
Oh, that's
and
the
graph.
stuff.
Notice how it's different, right?
Yeah, because it's a different slope.
The lines are a little, well, we're not really talking about slope.
But you know what I mean. It's more steep.
Okay, this will do all of that for you. And so for right now, I want you sketching the graph and using your calculator to help you. I'm really focusing on the domain and range more so than the graphing itself, because the graphing itself we're going to pick up. Now the word problems I definitely want you to graph by hand because those are easy to do, like the automotive one we
Wait,
did.
so we don't have to graph these when we do our calculator?
You do, you're going to sketch it, but you're going to use your calculator to help you. Yeah.
Sounds like it must have math number, but I don't know what it is.
Wait, what is it?
What are you trying to do?
I don't know, you said something, but then I.
Over to number ABS, option 1 is absolute value. Option 5 is the integer function.
Okay.
Before I drop this, that everybody, other than the Inspires, that everybody can get these graphed on your calculator. Because I really just overviewed on sketching the parent graph. Yeah. You can. Do you have an 83 or an 84? Oh, you got a Casio. I'm gonna have to look and see where that option is for y'all. It's on the video. At a bare minimum right now, I want you to be able to graph the parent step function, the parent absolute value, by hand accurately by points, okay? Like without the calculator. Just the basic step function for greatest integer of x.
So we do use graph paper.
No, you don't. But tomorrow, because what's going to happen is tomorrow we're going to take those basic parent functions and we're going to start shifting them, stretching them, shrinking them, flipping them. So you have to be able to do that base parent function
You're going to show
first,
me how to use
okay?
this thing is so confusing.
Woo!
I don't understand.